have you ever stopped to think about what's really next? I mean, beyond the digital age we're living in now. Today, we're going to take a look at a massive national mission to build that very future. A future powered by the incredibly strange and powerful rules of quantum physics. Let's dive in.
This sentence right here, it really nails the sheer scale of what we're talking about. This isn't just about making faster computers. It's about taking two giant fields, quantum mechanics, the physics of the super small, and information theory, the language of our computers, and smashing them together. And when they converge, you get, quote, transformative new capabilities. That's the whole ballgame.
So what exactly is quantum information science, or QIS? Well, like the slide says, it's using quantum physics to handle information. But what does that really mean? Think about it this way. A normal computer bit is either a 0 or a 1. Simple. But a quantum bit, a qubit, can be both 0 and 1 at the exact same time. It's like a spinning coin. Before it lands, it's not heads or tails, it's in a state of both possibilities. That one single weird idea completely changes the rules of what's possible with computation.
Okay, but how do you take these really mind-bending concepts out of the physics lab and turn them into something real? Well, that takes a serious plan. And that's exactly what America's Quantum Initiative is. Not just a few scattered projects, but a full-blown national strategy to build this new frontier.
Back in 2018, the starting gun went off. The National Quantum Initiative Act was passed, and it set a really clear goal: speed up quantum research and development to boost the country's economy and keep it secure. This was the moment quantum went from being a niche academic pursuit to a central piece of national strategy.
And this timeline shows you, this isn't just some passing fad. This is a sustained, long-term effort. You can see the whole story here, from the initial call to action in 2017 to the big act in 2018, all the way to things like setting new standards for quantum-proof encryption in 2024. It's a deliberate, step-by-step, government-wide push.
Of course, a big national strategy is one thing, but you need the resources to back it up. So to really understand how serious this is, you just have to follow the money. And there it is, nearly $1 billion. That's not the total. That's the budget request for one single year, fiscal year 2025. That is a massive, strategic bet on the scientific foundation of our future.
And look, this isn't a one-time cash injection. This chart shows it all. Since this whole thing started, federal spending has consistently been right around that $1 billion a year mark. And that sustained funding is absolutely critical, because quantum breakthroughs, well, they don't happen overnight. You have to build that momentum year after year.
Now, what's really important here is where the money is going. It's not just in one bucket. It's spread out across the Department of Energy, the Department of Defense, the National Science Foundation, and others. Each one brings its own unique expertise to the table, and that creates this really powerful collaborative network.
Okay, so this is the big question, isn't it? We see these huge numbers, but what does it all mean in the real world? What are we actually getting for that investment?
Well, it turns out you get a lot. We're talking about real, concrete progress, like demonstrating algorithms on systems with 48 logical qubits. Now, logical qubits are the holy grail. They're robust, they correct their own errors, they're a huge step toward actually useful quantum computers. Or how about tiny, chip-sized atomic clocks that can help you navigate when GPS is down? Or quantum sensors for navigation. This is where the money turns into actual innovation.
And all those big picture breakthroughs are built on this kind of work, which is just mind-bogglingly precise. What you're looking at here is a picture of researchers trying to line up quantum dots, which are a type of qubit, with an error margin of just 10 to 20 nanometers. To put that in perspective, that's about 1/1000th the thickness of a piece of paper. This is the kind of painstaking, microscopic engineering that makes the whole quantum future possible.
But this whole initiative, it's about so much more than just funding labs and publishing research papers. It's really a holistic plan to build an entire nation that's ready for this quantum future, from grade school all the way to the factory floor.
And the way they've structured this whole strategy is around a really smart, simple framework. 6 foundational pillars. The idea is to make sure every single part of this new quantum ecosystem is growing together.
And here they are: science, workforce, industry, infrastructure, security, and international cooperation. Together, these 6 things form the complete roadmap. So let's take a quick look at what that actually means in practice.
So let's just run through them. Science means a science-first approach, just fueling pure discovery. Workforce is about creating a quantum-smart generation of people, starting as early as K-12. Industry is about building a commercial ecosystem so companies can actually use this stuff. Infrastructure means making sure researchers have access to the super expensive, cutting-edge tools they need. Security, this one's huge. It's about developing new kinds of encryption that even a quantum computer can't break. And finally, international, which is all about building partnerships with allied nations. You see, it's really a whole-of-nation approach.
So you see all this progress, all this investment, all this strategic planning. It really feels like we're on the edge of something huge. So what's the ultimate goal here? What is this all building towards?
And this might be the most important thing to get. This is not a race to build one shiny quantum gadget. It's a marathon. It's a mission to patiently, deliberately, and carefully build the deep scientific foundation that will support the entire next generation of technology, whatever that may be.
The building blocks are being put into place, one tiny, incredible discovery at a time. From aligning a single qubit to signing global agreements, the quantum future is arriving. And that leaves us with one final, pretty fascinating question. Are we really ready for what this new power will unlock?